Welcome to Brain Vision.
This is question 5.116, friction and climbing shoes. So we have these special shoes made for bouldering and rock climbing that might have, we're told, a coefficient of static friction of about 1.2 and kinetic friction, coefficient of kinetic friction of about 0.9. So this question asks us, for a person wearing these shoes, what's the maximum angle of a smooth rock that can be walked on without slipping? So if we think about, we want to set up our equation, the sum of the forces is going to be equal to mass times acceleration. But of course, the acceleration here is 0 because we want to consider moving without slipping. So we're going to want the frictional force, and this is going to be a static friction force because we don't want the person to be slipping at all. We want that to be equal to the gravitational force, which is going to be opposing it. So if we think about the gravitational force on an incline like this is going to be equal to m times g times the sine of theta. Let me just bring that over here. Okay, so mg times sine of theta. That's going to be the component of the gravitational force pulling down on this person's foot on an incline. And the frictional force is going to be the coefficient of static friction here, again, because we want to consider motion without slipping, times the normal force. And the normal force of an object on an incline is going to be m times g times cosine of theta. So we can see this from just drawing out any of our free body diagrams of an object sitting on an incline. So if we look at this, we have an m and a g on both of these terms here. So we can just cancel them out. I'll just write this on a new line. Mg will cancel. And now we have, we want to solve for theta. So let's bring over the cosine to the side, divide by cosine. And now sine over cosine is just equal to tangent. So we can actually just say that tangent of theta is going to be equal to mu s. And mu s here is 1.2. So when we solve for theta, we just want to take the arctan of mu s, which is 1.2 here. So when we solve for this, we're going to end up with theta equals somewhere around 50 degrees, which is choice B.